Start. Welcome everybody to the March meeting of Stockton Astronomical Society. We'll get right to our program here in just a moment. First, refreshments. And Casey has an announcement as to what our refreshments are and why they are what they are tonight. Casey, tell us about our refreshments.
Okay, I don't have to go there. Our today is Pi Day, March 14th, and so we have some nice boysenberry pie and lemon cream pie from Eclipse Nation.
All right. Well, thank you so much.
We
For
can
us,
use more people here at the meeting.
No, we don't want.
I mean, we have enough people.
You guys are.
Yeah.
Zoom guys, you don't get it.
Listen, I want to buy. So, okay, call the meeting to order. And I'm going to go ahead and introduce our speaker and let him get started here. And then we actually have three kind of segments to the presentation. And so we'll follow up with the second and third ones and then our announcements and more pie. So our speaker tonight has been a member of the SAS since 1990, and he's been observing since he was 9 years old. And he has degrees in mathematics and a master's degree in teaching. He has served as an airborne astronomy ambassador on the NASA SOFIA program. He taught school for 37 years, approximately 1,500 students. He's owned over 20 telescopes, viewed multiple total and multiple annular eclipses, both on center line and off. He's been to Hawaii, Nevada, Snake River, Canyon, Malibu, Iceland, and the Philippines to observe. He holds astronomy certificates, Messier certificate, Herschel, a Herschel 2 certificate, binocular, deep sky binocular certificate, an outreach award, and the Caldwell Observing and the John Hewitt Memorial Award. So there's a list of accomplishments for you. He's personally made over 400 mirrors himself, and I believe that's what he's doing now in his retirement. You can call it a retirement. The guy's busier now than he ever was. But I've always been impressed by Jeff from the first time I met him in person, and I think that was at a star party. His knowledge of the night sky is unparalleled. If you ever go to a star party and Jeff's there, what you want to do is set up your telescope right next to his and just sit there and wait for him to invite you to his telescope. And you don't have to do any work. You just have to observe and listen to get an education on whatever you're observing. Jeff Baldwin is our speaker tonight. And Jeff, I want to welcome you and thank you for your presentation in advance. So let's welcome Jeff.
Thank you, Tim. Okay, before I start, there's a couple things I want to mention, and I don't see Ed Ribel on here. Today's his birthday, so happy birthday, Ed. He was born on Pi Day. So if you're watching this on recording, happy birthday. The other thing I want to mention is that we lost a member in the past couple months, another member. So you all know and love Crash Soros, and her husband, Joe, which comes to a lot of meetings, passed away on January 4th. And so I don't know how many people know that or not, or if I'm supposed to even be telling you about it, but we lost Joe. So I'd mention that before I get started. All righty. Eric, I have the ability to share screen, right?
You should, yes.
Dad, how do I do that?
For a button that says share screen on the bottom.
Oh, the big green one that says share screen.
Yeah.
Got it.
That's the one.
Asking if he wants some pie.
Ask me what? Or do I want to know?
What's the pie?
You bought pie?
Casey brought pie. It's Pie Day.
I know it's Pie Day, but heck, why do you bring it when I'm clear up here?
Because you're clear up there.
Thanks for nothing. Okay, here we go. I'm assuming you all can see my Grand American Total Solar Eclipse 2024.
Yep.
Do you have my like pictures of people along the side here too?
No.
Okay, good. Then that means I can continue on. All right, I'm going to start now. I'm Jeff Baldwin, and you're not. So here we go. Okay, total solar eclipses are really awesome. I mean, they are beyond anything you can imagine. Whatever you've ever observed in astronomy, it's pale in comparison. The photographs don't do it justice. So this is one of my crappy pictures from 2017. And that's not even what it looks like. But I had to have a picture of an eclipse, and I didn't want to steal somebody else's, so I stuck one of my weird ones on. But they are a very bizarre thing to watch. And so, first of all, I want to explain what a total solar eclipse is. So there's three kinds of eclipses. The lunar eclipse is when the Earth is between the moon and the sun. And a solar eclipse is when the moon is between the Earth and the sun. And the apocalypse is when the sun is between the Earth and the moon. This is a joke where you're all supposed to laugh hilariously right here.
We're laughing.
Okay, good. I can't hear. So I'm just gonna pretend that was funny. Obviously that can't happen because in this picture, this is to scale. Here is the Earth and here is the moon, and that's how far they apart in comparison to the size of the sun. So we can't have the apocalypse type of eclipse. But in seriousness here, what we're going to have is the moon is between the sun and the Earth, and it will cast a shadow onto the Earth. Now, the shadow isn't going to be that big. The shadow on a total solar eclipse is fairly small. This one's going to be about 120 miles across. On an annular eclipse, the shadow doesn't quite make it to the Earth because the moon appears too small. But I talked about that in October. I'm not going to go there now. So this is a total solar eclipse where the moon is between the sun and the Earth, and the moon, from our point of view, looks larger than the sun. So there is a 1 to 400 ratio between the size of the moon and the size of the sun. There is a 1 to 400 ratio with the distance to the moon compared to the distance of the sun. Therefore, they look the same size. They both look 1/2 of a degree in the sky. And that is, a miracle of our particular environment here. The other planets don't get that. So sometimes, because of elliptical orbits, the moon looks a little larger and the moon looks a little smaller. And sometimes, because of Earth's elliptical orbit, the sun looks a little larger and the sun looks a little smaller. So sometimes it's not a perfect match. So sometimes the moon looks smaller and we have an annular eclipse. And sometimes the moon looks larger and we have a total solar eclipse. And that's what we've got in April. All righty, here is the path for this eclipse, not including the oceanic parts. This is just as it's going over North America here. And so you can see that out here at Mazatlan, Mexico, it's going to drive itself through Texas, Arkansas, Oklahoma, Missouri, Illinois, blah, 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 all the way through New England here. So I'm going to zoom in a little bit. By the way, I stole this from, I think I stole this one from Astronomy magazine. So here is our side of it. California is way up off the screen here, and we're only going to have about a 45% eclipse here, which isn't the worst thing in the world, but it's absolutely nothing compared to totality. So Mazatlan's pretty close. They've got a 4-minute eclipse. Somewhere right around here is where the eclipse is at its greatest length. My nephew Eric and his family are going to go to Mexico to see it around here. They're going to fly to Monterey and drive over. I am going to be on the Texas border side. I'll be up here near Kerrville and Fredericksburg. So Austin is in the eclipse, but they've only got, less than a minute because they're on the side of the path of totality. Dallas has a pretty good one, but they're not dead center. Fort Worth is a little bit worse. I'm going to go ahead and click out of Texas, Oklahoma, Arkansas, and move over a little bit to the east here. And so here is the Indiana area, the Ohio area. Cleveland is really close to the path. Cincinnati got missed. Rochester, way to go. And I guess Buffalo, I think, is right here. If Paul was hooked up with this, he could tell because he's from Buffalo. I'm referring to Paul Kovacic. So Buffalo's on it. And then it goes through Maine and out through the Canadian Maritime provinces over here. So that's the path, but I'm going to go back a slide. This is where we're pretty much interested because we live over here. And this will be not only a longer eclipse, but a higher probability of weather eclipse. And it's closer to California. So a lot of Californians are going to be between
Back, you had them.
Mazatlan and maybe the corner of Oklahoma there. Alrighty, so speaking of weather, this is the bad news about the eclipse. This weather has orange is bad and blue is good. Now this is the typical weather pattern for midday, April 8th over the past kabillion years, averaged up. So in Mexico, where the eclipse is longest and highest in the sky, they got really a high probability of clear skies. And the second you cross that Rio Grande River, goes down immediately to roughly 50%. Now, if the eclipse was just a little bit further to the west, we'd be okay. But there's this line here in Texas where on that side of the line, we got the humid, lesser weather. And on that side of the line, they have the drier, clearer weather. So we're about 50% here. And as you head up towards New England, it gets worse and worse and worse and worse and worse. And the eclipse gets shorter and shorter and shorter. I have a friend in New York. He's the head of the Stellafane telescope making workshop, and he's going to be over here just a little bit northeast of me. And so we're going to meet for lunch over there the day before, but he lives and works over here, but he's coming all the way down here to see the eclipse. I got a sister in Indiana. She's going to have to drive about a couple hours to get up.
Hey, bud.
All righty. So I'm going to try to move this thing out of my way. Oh, yeah, baby. There we go. Okay. So in Mexico, the sun will be due south. It'll be 70 degrees high. It's going to be about 1:20 in the afternoon, their local time. And it most probably will be clear. I have a bunch of reasons why I do not want to go to Mexico. And so I'm going to stay on this side of the river, which really messes up my weather probabilities. I'll be near Fredericksburg. I'm going to be on a ranch down there. The sun will be almost 70 degrees high. It'll still be 1:30 in the early afternoon. But again, 50% chance of bad weather. Here in Stockton, you're going to probably have good weather. And it's going to be about 11:30 in the morning. It'll be 52 degrees high, but you are not going to have totality, but still be worth watching. Like any other partial eclipse, but it won't be, the real deal. Indiana, 52 degrees high, be 3 o'clock in the afternoon, and only a 30% chance of clear skies. And in New England, it'll be a little lower later in the afternoon because now we're in Eastern time and the sun is going to start looking like it's in the southwest, but only a 15% chance of clear skies. So even though there's going to be 30 to 40 million people available to be on this path, either on it or close enough to be on it, chances are 1 million are going to see the eclipse because of the lousy weather predictions. Of course, you never know. You just never know. Okay, so here's another weather prediction issue here. Stockton's okay, but no totality. Okay, and I showed this one in October, but I just want to emphasize that there are 2 eclipses passing through the contiguous United States. October, we had the annular eclipse, which was cloudy, but I got about 3 seconds of annularity. And then Fred Lusk was down by Moab, and he had clear skies. So it just depends on where you're at. Then this eclipse is this blue one right here. I'm following with my laser pointer. And as you can see in the contiguous United States, there are no more eclipses until 2044. So since this chart goes to 2040, it doesn't show them. We got one going through Barrow and Nome, and I can't remember, I think it was 2033. And but as far as the contiguous United States, this is it for a long, long time. Okay, now I want to emphasize that thing in the yellow. Make sure you read it. Absolutely at no point during partial phases is it safe to look at an eclipse. Naked eye, binocular, telescope, nothing. It will destroy it. You won't know it's destroyed. It won't hurt, but it might take a couple days before you realize you blew it, but it is a deal buster. Now, that's not only your problem, but as the astronomer in whatever little group you're with, friends, family, kids, students, you're the responsible person on this. So if you got 15 parents and 43 kids, it doesn't just lie on those parents. You're the astronomer. You are the official smart person in the group. It kind of is your problem to make sure nobody looks at this thing. It's permanent. Now, during totality, not a problem. But if during any partial phase, it is a no look. There are projection methods that are very, very safe. And so I'm hoping that Tim brought his solar projection scope, and I don't have it on my little checklist here, but I'm hoping that Eric brought his funnel scope. Both of those are really good. One of my favorites is just to take a secondary mirror out of a telescope, put it on a camera tripod, and reflect the sun on a wall somewhere. When you do that, the sun will be 1/120th the size compared to the distance away that the reflection is. So if your reflection is 120 feet away, it'll be a foot across. If it's 60 feet away, it'll be 6 inches across. So not only will it be that size, but it will have the crescent shape because the moon will be blocking the sun. So it will show you the partial phase of the eclipse very well. Another one is just take a piece of paper, poke a hole in it, and hold it in front of you. And look at the shadow of the paper on the ground. And in the center of that piece of paper will be a little eclipse there. If it's cloudy where you're at, if you just can't get to a location where you can enjoy the eclipse, then it's okay to watch this on TV and on the internet. The nice thing about the internet is they'll have it at Mazatlan, then they'll have it at Del Rio, then they'll have it at Dallas, then they'll have it in here and there. You can watch the eclipse over and over and over and over and over from coast to coast. You could watch an eclipse for an hour or so. During totality, no filter is required. As a matter of fact, a filter would be a deal buster because the filters at 1,000,000 times the light. So not only would you not be able to see it, but it's unnecessary during totality. That's from second contact to fourth contact. The second that sun pops back out or before it pops in, it is a filter required event. Okay, now this is just kind of a chart that I pulled off of, I can't remember what magazine it was. Might have been Astronomy or Sky and Telescope. Could have been website. I don't remember. But it goes from Dallas to Caribou, Maine. And so as you look at this, you can see that the time of day gets later and later and later, and the duration of the eclipse gets shorter and shorter and shorter. So in Dallas, 140, 142, that is a 4-minute eclipse. It's at 1:42 Central Time. Oklahoma, this one is 4 minutes. Arkansas, this one is only 3 minutes, and it's not because it's shorter, it's because it's not on the center line, right on the nose. This one in Missouri, back up to 4 minutes. Down here in Kentucky, it's down to 2 minutes, but that's because they're not on the center line. And down here in Illinois, they're 4 minutes. And in Indiana, they're at 3 minutes. And then we finally get into the Eastern time zone. Cleveland's 4 minutes. Erie, Pennsylvania is 4 minutes. Buffalo, New York is 4 minutes. Vermont, we're down to 3. Lancaster, New Hampshire, we're down to 3. And in Caribou, Maine, we're down to 2 minutes. And so you can see that 1:42 Central Time running itself up to 3:30 Eastern Time. That, coast to coast, about an hour, roughly Okay, Brand, you can do this. About an hour's worth of stuff there. It looks like 2, but it's really an hour. From Mazatlan to Caribou is a little bit over an hour. That shadow's going to travel, 3,000 miles in an hour because it's going 3,000 miles an hour. Okay, if anybody wants to interrupt me, please do so. Okay, so here's the things that you kind of want to look for. There are others, but these are the biggies. Before the eclipse, as the sun starts becoming covered by the moon, it will get cooler. So the day, especially like in Texas, it's going to be middle of the day, 1:30, in the afternoon. This temperature is climbing and climbing and climbing. So as the moon covers the sun, it will not only retard the climbing temperature, but it might even reverse it. It might get cooler. Might not, but it should get about 10 degrees cooler for 4 or 5 minutes. And then it will resume its heating during the day. So you should notice it's cooling down, and then it will again warm up. There will be a remarkable dimming effect. You're going from broad daylight to a little bit brighter than if a full moon were illuminating the ground. So that's about 500,000 fold in brightness difference. One thing I enjoyed was at the end of the eclipse, when the sun pops back out and is starting to re-illuminate, at first, everything looks like it's the wrong color. I've been thinking about this. The photosphere is illuminating the ground during the day. Then when the eclipse is over, it's a sliver of the photosphere that's illuminating the ground. So the color should not be different. So I got to thinking, I could be wrong. Maybe Mikey, maybe you can help me on this. When it's full day, your red, green, blue cone receptors are in their balanced natural state. Then we have the eclipse, and then when that sunlight starts to peek back, and we have this right color of sunlight, but only a little bit of it, perhaps the red, green, and blue sensitivities are going to kick in at different times because some are better than others. I know we see green the best with the human eye, but red is kind of the nighttime flashlight coloring stuff. Perhaps those three are not quite balanced when it's not fully bright yet. So maybe that's why there's an illusion that the colors are wrong. I do not know. I'm just making this up as I go. If anybody happens to know a good reason for this, please interrupt me. I do not get upset being interrupted. You will notice, at least where you are at a place where there's totality, you won't notice this in Stockton, but where there's a place of totality, you'll notice that the birds will quit chirping for a few minutes and then come back. The bugs will quit doing their thing. It would become still and eerie, except for the fact that there will be a few hundred people around you screaming and hollering because, hey, it's an eclipse, isn't this cool? So that kind of wrecks the whole still and eerie thing. But if you can get away from all those guys, it will become still and airy. My first eclipse in '79, I was clouded out of it, but we were in the middle of nowhere. It was me and 2 other guys, and it was freakishly dead silent during the totality of that. It was kind of weird. It was also cloudy, which made me incredibly angry. Okay, the things also to look at, obviously the corona is the big deal for a total solar eclipse. You don't get to see the corona unless you're at a total solar eclipse, or you go into outer space and put your thumb in front of the sun. But also you can see the chromosphere and the prominences along the limb of the sun. The moon's in front of the photosphere, get rid of that intense brightness, and the neon pink chromosphere and prominences can be seen next to the moon. They're on the sun, but you see them next to the moon. So just at the beginning of the eclipse, you can still see that 120-mile thick chromosphere atmosphere on the one side. Then the moon slowly moves over and covers it up. Then at the end of the eclipse, it moves over and you can see that 120-mile thick chromosphere on the other side. Then you get the arc welded bright sun that's over. But you also see the loops coming off the sun. Now, at the 2017 eclipse that we went to, most of us went to Oregon, Wyoming, Idaho. I think Eric might have gone to, I don't know, Tennessee or South Carolina. We were at a solar minimum and there was only one really good prominence. There was a couple other little ones, but only one really good prominence. Fingers crossed, the sun will be very active and there will be prominences all over this thing. That's what we're looking for. I might go back and look at the sunspot patterns over the past month and try to see the timing of which ones will be on the limb of the sun predictably on April 8th. And that might give us a clue what prominences we might see. And I could be full of crap, I don't know. Alrighty, we can see planets and stars. So we'll be able to see Jupiter, Venus, Saturn, Mars, and Mercury, as well as the sun and the moon. So that's 7 solar system objects in one view right there. If you're interested, you should be able to see, I got a picture coming up. I'm going to wait for that until I show you that picture. So I'll hold off on that. Shadow bands. As the slit between the sun and the moon gets thinner and thinner and thinner, as a slit of light goes around an object, it sets up a diffraction pattern. And since it's actually moving and getting thinner, the diffraction pattern periodicity is changing. And so what you see is these dark bands running along the ground. It's approximately a minute before second contact and a minute after third contact, but it's worth looking for a longer period of time than that. So they're called shadow bands and they're pretty cool. They're just these dark lines running along the ground. They're very subtle and they're hard to photograph. But if you have some beach sand or some canvas or white wall building, look for them. It might be one of those peripheral vision things. I think if you look right at it, it might be a little more difficult because they're very subtle. Okay, so when the moon covers the sun and the temperature goes down, especially if you're in a humid place like the eastern side of the United States, clouds can condense. And so the worst nightmare is you got a beautiful clear day and here comes the moon covering the sun and all of a sudden, boom, clouds grow because they condense in the colder air. Good luck to all of us against that one. The one that I've always liked is the emotional reaction that you have during eclipse. I wasn't ready for it. I always tell people it's like being hit with an emotional baseball bat. You just can't believe what you're looking at. And it's a whack job. It's exciting and thrilling and very emotional. Believers will actually have religious experience involved with it. Even non-believers will have, a near spiritual event. It's really amazing. Okay, so just before totality starts and just after totality ends is the diamond ring effect. And that's when the sun is, the moon is black and it's got like a ring around the moon. And then a little bit of the sun peeks out and it looks like a diamond on a diamond ring. So that's called the diamond ring. It's pretty. So I did have one experiment I thought I'd try, but the more I think about it, the more unlikely I am that I'm going to do it. That is, at nighttime, I can pick up radio stations from I could pick KGO in San Francisco up from Canada. Daytime, I can't get it for more than 100 miles. So I'm thinking of tuning my radio to KGO and just listening to static and seeing if KGO will come in when the moon's in front of the sun. Now, I'm not sure if it's the solar disk that will prevent that or if it's the corona energy that would prevent it. So I don't know what I'm doing, but I thought I'd commit that experiment. Or not, we'll see. If anybody does do that, please let me know how that turned out. Okay, so on the right side here is the diamond ring effect, and that's when the eclipse just comes to an end and a little bit of the sun is peeking out and it looks like a wedding ring with a diamond on it. And on the middle picture is Bailey's beads, and what it is if you can look at this thing on the left here, here's the edge of the moon, and I have exaggerated the roughness. And as the sun starts to come around the moon, in the valleys, the sun will peek out. And so what you'll see is you'll see a dot. Then since they are in motion, a little while later, more sun peeks out. So you get more dots and they're more intense. And then more and more and more and more until finally it's too bright to look at. So you get this on the way into the eclipse and you get this on the way out of the eclipse, and they are called Bailey's beads. At first, when the eclipse comes to an end, if you're looking at a telescope and all of a sudden that sun just starts to peek out the other side, looks like arc welders are lined up on the side of the moon doing some work on the moon. It's pretty cool, but you don't want to keep looking because, dude, that's bright. And I mean bright. I like burn your eyeball out bright. Okay, so here are more of my crappy eclipse pictures from 2017. This is the chromosphere, this red thing right along here. So on this picture on the left, the moon was kind of on the right side and the sun was kind of on the left side just after totality started. And so the moon is covering up the chromosphere, the photosphere, the bright part, but a little bit of that chromosphere atmosphere could still be seen around the moon. And then the moon continued on and you couldn't see it. Then at the other end of the eclipse, you could see it on this side. So it is the hot pink, electric neon pink chromosphere. And over here is the exact same material, hot electric pink, only that's a prominence protruding from the sun. So here's a longer exposure of the same thing. Here's a chromosphere, here's part of the corona, and here's a loop prominence. And they're pretty cute to look at. And you can look at these with a hydrogen alpha scope, but they're blood red in a hydrogen alpha scope. In an eclipse, I was expecting them to be blood red, but they turned out to be a hot neon pink. And I guess it's because hydrogen isn't the only chemical that is being excited and emitting light. So you take all the chemicals that are being excited and emitting light all together, they look more of a hot pink than a blood red. And then, of course, the holy grail of it all is the corona. This is your only opportunity to see a solar corona. And it's gorgeous. No photograph can do it good, and especially one of my crappy photographs. So I tried stacking short and long images together to get detail on the outer corona all the way down into the inner corona. And this is as good as I can do. I'm hoping that Jason, Mark, and Omar will help me out, and maybe I'll get a better shot this next time. Well, this is taken through my astrophysics. It's got a 1,000 millimeter focal length. And as cool as that is, the moon is so big that I don't get a lot of corona. So this time around, I am piggybacking on the astrophysics will be Jason's 400 millimeter telescope that I'm going to take pictures with. And so the sun will be smaller and I'll be able to get more corona because who cares about the black disk? You're after all that cool feathery corona stuff. So it's a moot point because it's going to be cloudy where I'm going to be. We all know that. But if I'm lucky, I'm hoping to get better pictures. Okay, this is what I was going to talk about. I decided to shut up until this slide. Right here's the sun and the moon. And notice the moon is not in front of the sun. Sorry. I got this off of Heavens Above and I couldn't manage it. So what would happen? So I just said, I'll live with this. So right here is where the eclipse is. And to the left, you should easily see Mercury and very easily see Jupiter. And to the right will be the brightest dot in the sky, Venus. It'll be magnitude -4. And then over here next to each other will be Mars and Saturn. So you'll be able to see Mars, Saturn, Venus, Moon, Sun, Mercury, Jupiter, and Earth all at the same moment. That's 8 solar system objects at the same time. That'll be a record. Now, you can also see, okay, in Texas, you can see Canopus. You can't see Canopus in Stockton. You can in San Diego, but you cannot in Stockton. Where I'm going to be in Texas, you can. So I'm going to look for Canopus, Sirius, Rigel, Betelgeuse, Aldebaran, and Capella. Those 6 guys ought to be a real snap to see. On the other side, we've got Altair and Fomalhaut. I'm going to look for a little bit, but the last thing you want to do in an eclipse that's so magnificent is spend the whole time looking for some stupid star over on the other side. So don't spend any time working at finding those guys. Enjoy the eclipse. You're going to be a long time before you see another one. Okay, so there are methods of observing before and after totality, and then there's methods of observing during totality. And this is a recap. When it is partial phase, filters, 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 period. Oh, I forgot one, filters. Okay, or projection scopes or methods, holes and cards, Shadows of tree leaves is great because you look at the shadows of tree leaves and there's like a couple hundred shadows and they're all shaped like a little eclipse. It's pretty cool. Reflecting a mirror onto the wall. Some people like to use black and white photographic film because the silver content in it will, when you develop an exposed negative, it acts like a filter. I do not recommend this. I would just say, go get yourself a professional Eclipse filter. And there is welding glass, number 12. I think it's number 12 you're supposed to use. I'm not gonna recommend that either. If you burn your eye with an Eclipse filter, sue those guys. If you do it using welding glass, there's nobody to sue. Plus, I don't know if it's safe or not, so I'm not gonna recommend it. During totality, you don't need a filter for the scope, you don't need a filter for the binoculars, and you do not need a filter for naked eye until that sun pops back out, and then filter, filter, filter. Okay, so after the eclipse, you're probably going to want to write some notes, what you saw, document it somehow so you can, remind yourself and tell your friends and family about it. You're going to want to get your pictures to the newsletter and bring them to our meeting. I think we have a program in May, so it might be the June meeting that we're going to be able to share out our eclipse pictures. So make sure you get them to the newsletter and get them to the meeting, because that's going to be the whole fun of this, is sharing this with your friends. I'll be bringing pictures of clouds. And of course, start planning for Iceland in 2026. That's going to be, Glenda, are you hearing this? I'm kind of hoping that she'll go along with that. Iceland is kind of a ways to go, but heck, might as well check out Iceland. Iceland is cool, in case you haven't been there. It's pretty cool. Get it? Cool. Burr.
Land of fire and ice.
Okay, so to photograph the eclipse, I'm going to tell you how to do this because I'm an expert. You ask Jason, Omar, or Mark. That's how you figure out how to take a picture of an eclipse. So I'm going to stack exposures of different lengths of time, and then that way I'll be able to get the dimmer part of the corona way out and the brighter part of the corona way in, and hopefully equalize them all out to get it evenly balanced all the way from outside to inside. And of course, I'm going to have to help with that because I'm kind of stupid with computers. I'm kind of stupid with cameras. I am going to use a 400 millimeter focal length because 1,000 millimeters was too long. I got more moon and not enough corona. So my suggestion is limit your focal length to 400 millimeters on a standard size sensor. Photographic film, an inch by an inch and a half, you might limit it to 600 millimeters. Spend time looking and enjoying it. If you could really get fixated on taking pictures and managing equipment and stuff and miss the best part of the eclipse, the holy crap, look at that effect that you're not going to believe. So go ahead and take pictures, but do it automatically while you're looking at the eclipse, because the eclipse is just too cool to look at to miss it. Okay, so here are the upcoming ones. This one, 2024, Iceland 2026. Spain, Egypt, 27. Australia, 28. That one kind of interests me, Glenda, if you're listening. South Africa and Australia in 2030. That one interests me too, Glenda. Panama in 31. Nome and Barrows, Alaska in 33. That one really interests me. Going up to the Arctic Circle and seeing an eclipse, how cool would that be? And then 2034, Nigeria, Egypt, Middle East, and Tibet. There are a few more, but of course, the next one in the contiguous United States is 2044. Let's face it, I'll be dead. I'm not gonna be old, I'll be gone. And if I'm not dead, I'm never gonna be able to drive to New England to see that because I'll be 5 million years old. So I really plan on enjoying this eclipse. Fingers crossed. Okay, now, that is actually the end of this, but I have a couple of videos. And the first one is shadow bands. And the second one is actually seeing the moon's shadow moving across the sky. So I am not going to promise that I can pull this off, guys. And I probably look like an idiot doing this. All the tech guys out there going, all I gotta do is go back plus 7-star asparpam or whatever. Let's see if I can pull this off. Come on, come on, come on, come on. All right, so I'm gonna run this video. I think there's a commercial first. No, there's
We
not.
don't see it on the screen, Jeff.
You don't see it?
No.
Okay, give me a minute to
You
go.
might need to share out the screen that has the video on it.
That's what I'm gonna do when
Or move it from screen to screen or something.
um set the green button. Hang tight while I adjust this. Y'all seen my
We do now, yeah.
okay, good. Okay, here we go. Thank
Can
you,
you
Eric.
can you expand it though? Make it more
I'm getting
full
there.
size? There you go.
Okay, now do you hear the audio on this?
Yes.
Let me kill the audio on that.
Flying shadow, very
Oops. Okay, so I just killed my audio, which means I can't hear you guys. So we'll pretend that this is working out. So I don't know if you can see the motion that's going on the screen, but those are shadow bands moving. I'm going to advance a little bit, and there they are. So that's pretty freaky to see when you're at an eclipse. And I'm going to try to focus on this when I'm at this eclipse. And this is not fake. This is a real thing. Okay, so I'm going to stop that, and I'm going to bring my sound back. I'm going to ask you guys, were you able to hear me while I just said all that?
Yes.
Okay, good. Now, I'm now going to go to the other video I wanted to go to. Give me a second to goof around here. I apologize for this strange pause in the game here. I'm not a tech guy, so don't be laughing at me. Doug, no laughing. I hear that.
But I'm not a tech guy. Not as bad as you are.
Okay, do you guys see my new screen?
Yes.
Okay, so I got to check one more thing here real quick. Okay. Okay, I'm going to move this up to about a minute and a half. So this is let me kill the sound. Okay, so this is a high altitude balloon that's showing the Earth's shadow, but that's not what I want to show you. I wanted to show you, and that's not the right video. Doggone it, that ain't the right video. There we go. Come on, come on. Okay, you guys can still see the thing that says Fort Laramie?
Yes.
Okay, good. I'm going to kill my sound. I won't be able to hear you yelling at me if you are. So I'm going to move this up. This is a high altitude balloon that goes up and does watches the Earth's shadow moving across it, but that's not what I want to show you. I want to show you what we can see from the ground, and it's somewhere right around here, and it's just going to last about 15 seconds. So here we go. This is the Earth's shadow in the sky moving across during an eclipse, and it is so cool. So right here, you can see it's dark here, but it's bright way out there. And then they go back up to the other thing there. So I'm going to kill this now. Bring my sound back up so I can hear. And then I'm going to try to one by one get rid of some of this junk without. Okay, can you all hear me?
Yes.
Yep.
And do you see my That's All Folks screen?
No, we still see
No.
the YouTube.
Well, tell you what, I'm gonna stop sharing because I pretty much exhausted that. Unless there's something back there you guys want to see. Can I go ahead and stop the sharing?
Sure, go ahead.
Okay, so well, okay, I don't have my game on here. This bar cuts across up here. Stop share. There we go. Oh, yeah. I'm not a tech dude. The whole thing just ticks me off. Anyway, that was my Eclipse show, and I'm curious. Maybe we can go around the room and ask people who's going to the Eclipse and where are you going? I'm going to Corville, Texas. Where are you guys going?
I'm also going to Kerrville.
Oh, cool. We're gonna have to talk.
Going to southern Missouri.
I did not hear that.
I'm going to southern Missouri.
Wow. On the center line?
Yes, we were gonna go find.
Awesome.
I'm going to cloudy Buffalo, New York. And then try
Cool.
to get Erie, Pennsylvania or Cleveland or wherever the weather is best.
I understand that even though the cloud prediction up there's awful, along the south shore of the lake actually isn't awful.
That may be where I end up.
Cool. Is that Pat I see?
Yeah. Yep.
Hey, dude, how you doing?
Good.
Anybody else going?
Heights. Parker Heights, Texas.
Oh, where's that at?
Probably, basically the same area you are. It's
Okay.
over by.
Okay, we'll talk. Yeah, cool. Anybody else?
Yeah, we're going to North Texas, a place called Pat Maisie Lake, which is just north of Paris.
And who's this? I don't see who's talking.
Casey Foley.
Hi.
She's
Well,
the one that called it pie.
Good luck on the weather there. I hope we all have good luck on the weather. Oh, there we go. Anybody else going?
Yeah, we're going, we just haven't decided. We'll be driving out of New Mexico, probably near Austin, but we may go up to visit family in Dallas.
Is that Mark I'm hearing?
Yep.
Cool. Well, good luck on your weather. Anybody else going?
Right? Oh, huh? What? Near Fredericksburg, some
Cool, cool, cool.
probably staying in Austin.
Well, this is, anybody else? This is great. I'm glad to hear that we have somewhat of an entourage heading over there. It'd be a bummer if we didn't, but bottom line is this is it. This is the one. This is, well, 20 years before we get another one, and it's even farther away. Okay, so I know that Tim and Eric have projection methods that they wanted to show on this. So I'm going to pass it off to you guys.
Thanks, Jeff.
Do you want to go? Want me to go? Let's see. What camera should I use?
Please tell me Eric is having tech problems. That would just make my day.
I don't have problems. I just have.
While Eric shifting gears here, I apologize. Were there any questions for Jeff or any other comments? I have a question. You showed us the shadow band.
Yeah.
So what's creating those shadows on the wall, on the earth, on the objects? What is creating those, Jeff?
Okay, if you take a light and pass it through a very thin slit, it will naturally separate into a diffraction band. And as you change the thickness of that slit or change the wavelength of the light, they change in their periodicity. Now, this is a broad spectrum light, but nonetheless, the wavelengths are all 400 to 700 nanometers. And so there is a generalization of bands. Now, they're not straight lines because the side of the moon is, rough. Now, if you change that slit, the bands change the periodicity. So from any point that you look at them, they look like they're spreading out or converging together. So when you look at that white sheet over there, you just see bands moving along the ground. And that's basically what it is. And I could be a little bit wrong on my physics, but I think that's kind of the ticket.
Okay, we'll fact check you, but we'll go with that one.
I do want you to.
Another question I had was, I've heard of these airliner tours. People get up in an airplane and follow the eclipse. Have you ever heard of that? And what are they doing? Are they flying multiple perpendicular paths to the eclipse so that you can look out the window?
Parallel, if you think about the eclipse shadows traveling along the ground at 3,000 miles an hour, way back in the day, I know the SST followed the eclipse and it was going 1,500 miles an hour. So they were able to extend the eclipse by about 50% on that. So if you get in an airplane that's going 585 miles an hour, it will extend the eclipse a little bit. But the eclipse, this eclipse is like up. And so you'd have to get out your window, go like that. And then, 400 people are going to get on one side of the airplane and look out. I kind of don't recommend it, but you can extend an eclipse. Also, since you're 7 miles or 8 miles high, you're technically a little closer to it. So you might get an extra second out of it that way. But the idea is just to run along with it to extend it a little bit. SR-71 would be the deal.
Yeah. Anybody else have any questions for Jeff?
Yeah, just, Jeff, earlier today I was reading an article that said that, Private Pons Brooks, the Devil Comet, may be, naked eye visible during the eclipse over between Mercury and Jupiter.
Hey, Jeff, can I take that one?
Yeah, absolutely. Please do.
Let me take that one but pause this because I've got a slide at the very end of the meeting. We'll talk about that then. And Jeff, stay tuned. Let's answer Pat's question then. Okay. Eric, you ready?
Bueno.
Sure. All right, am I on the screen here? Okay, so first thing I wanted to demo for you guys here. This is called the sun funnel. And it's just basically a funnel that you cut the end off. You can put an eyepiece in here. Grab some film. This film that I'm using just happens to be like a white vinyl shower curtain with a pipe clamp around the end to hold the film. And then you can stick this into I think we can use a Newtonian, but I've really only used it on a refractor. But I think either will work. On our website, there is a new page up on the website called Eclipse 2024. And there is directions on how to make this. It's a downloadable PDF document that will explain to you what the best eyepiece is to use with your particular focal length of your telescope and all that, with detailed instructions on how to make this. I think in the document, they actually have more of like a professional grade back projection screen that you can put on here. But that might be a little bit better, but I don't know if you can find it in time. But you should be able to just go and pick up some white vinyl shower curtain or even a tablecloth.
We have that at the
Okay.
storage room.
Okay.
We've got the material and it
Okay.
works.
Yeah, it does. So that's the first thing. The second thing I wanted to mention is also on the website is the PDF document explaining how to make the device that Tim has brought in the past, his little solar projection wooden apparatus. We don't have it here today to show you. We've shown it in the past, but you can see all about the directions on how to make that one as well. And then finally, this guy here is sort of a DIY version of the sun spotter telescope that is very expensive for what it does. And so this is just a small, I think, 8-inch square box. I put it on a little tabletop Dobsonian mount, but you can just use any old wooden L-shaped bracket to make this thing. It's like got a half covered slit here on the side, and then I have an old binocular aperture connected to some paper towel roll, and then a 45 diagonal to an eyepiece on the inside in here. And I have it set up so that you can slide this forward and backward as needed to adjust the focus. But it works really well. And in a moment here, I'll show you some pictures on the computer so you get a better idea of how this works. Give me a second here to share that out. Let me drag this over to the other screen.
Oh, cool.
And let me share this here. Okay, hopefully you guys can see that.
Yeah.
Let me minimize that there.
Was that picture taken at the annular eclipse?
This one was back on the 2017 eclipse, yeah. Not the annular one, not the one in October, but in 2017.
Yeah.
So like you said, I was in Tennessee and I took this to Tennessee. I was there with my relatives at their house. So I wasn't amongst a large crowd of oohs and ahs. It was just our immediate family, basically, on a cul-de-sac. I think I have a couple other videos. I mean, actually, that one I'll come back to in a second. But let me come back as more of a close-up, showing the eclipse there. And you can even see sunspots if with this device. So, and it's a pretty cool device because you can show it off to multiple people at a time. You know, more than one person can be looking through the open side there. So it's pretty good for groups. While I'm here, I'll go ahead and show you some of my eclipse photos. There's one, and then I double stack that to make that one a little bit brighter, and you can see the corona a little bit better. And then one more third stack to make it a little bit more brighter. Like Jeff mentioned, I think I think I just barely got the corona in there. I think I will change my focal length a bit as well. This was taken with 300 millimeter focal length, but it had a doubler on it. I forget the technical term for the doubler, but it basically made it a 600 millimeter focal length, which I think is even too close. Plus, I wasn't quite centered on it. So, like Jeff said, it might be better to have lower focal length. And this was taken with a cropped sensor as well, not a full sensor. So keep that in mind, because I think a crop sensor, if I'm not mistaken, makes it look even more magnified.
Is that a planet or star?
I think that was a star. Was it?
That was Regulus.
Yeah. So that's that. So those demos. Do you want to get into the other flyers? Yeah, I'm done. Thank you. Sure, yeah.
Was your mount still, or did you have a?
I had a tracker.
Thanks, Eric. It's amazing what you've done with the shower curtain and
Let me bring up this guy here.
why. Eric, shifting gears here, we'll talk about our announcements.
I'm sorry, on Zoom, can you see the announcements? The announcement slide?
Yes.
Yes, okay, very good.
The other slide deck.
Oh, you don't want to show this one?
Those of us staying in Stockton, there's a few of us. We should try to get together or go to, I'm thinking maybe Oak Grove Park or someplace, because I don't believe that Delta College is holding an event.
Probably will not be doing anything.
I don't know that we've heard anything that South Key County Office of Ed. Jeff, did you hear anything back from them? Are they scheduling any events?
I did not. I'm kind of waiting to hear, and it's kind of getting down to the wire, but I will pass anything along to you.
I don't think, I think Annie was saying that she didn't think there would be anything here. UOP still a possibility, we need to talk to Jerry. If not, we can Oak Grove, just hit Oak Grove.
I think I'm looking at everybody in this room that said they're traveling someplace except for me, so I'll put out an email and see what other members might join me locally here. So, since we're talking about solar activity, the eclipse, I wanted to bring back this article, this thing that came up just recently, and you all read about this in the Valley Skies. Doug wrote a nice article. So we want to do a little bit deeper dive and tell you really what we saw and what happened. And it's a little bit of the phenomena that was kind of serendipitous that Eric stumbled on it and we saw it together. Several of us were here. So here we are set up outside this building here for the STEAM fair that San Joaquin County Office of Ed had, where all the students and their families are coming during the day to get judged on their science projects and going through different exhibits. The Star Dome was set up, and the Gem and Mineral Society had a display. It's really kind of a lot of fun. So here's our team set up outside. There's Eric and Michael and Kathleen Chapman, and then some students that were attending. And so
Maria and Jose might be sitting behind Michael in the shade there.
Friend or companion there. So Eric, you had multiple scopes set up out there. You had, what is this one? And then what is this one here we're looking at?
This is the club solar scope, the 60 millimeter aperture Coronado solar scope.
Okay.
And this one is my personal 150 millimeter objective. They're both hydrogen alpha solar telescopes. And recently we've learned that the club scope has an issue with the
Coronado, the scopes.
Yeah.
Coronado.
Has an issue. It has an issue with one of the transmission filters in it, and we're looking at getting it replaced. It's a couple $100 replacement. It basically has a cloudy, rusty film covering that makes the image look much dimmer than it should. So hopefully we'll get that repaired pretty soon. I'm told it might be ready here sometime in March, and we'll just a simple drop-in replacement inside the mirror diagonals where it resides. So
Eric, that's the iron oxide filter.
yeah. It's not really iron. It has to do with silvering inside. And it has to do with how they manufactured it.
So is it like the lens coating that's coming off?
Basically, from what my understanding is, you have two glass lenses that are sealed together, and that seal it breaks, which lets moisture in, and then it, for lack of a better word, it's not really iron, it's not really rusting, but for lack of a better term, I don't know what you want to call it, but the moisture gets in, oxidizes, and creates a cloudy film in between the two layers. So
it's a good point. Y'all know that the club has the solar stuff. If you ever wanted to borrow it for personal use for an event, or just it's a loan. So anybody that's kind of train you up on how to operate it, it's great fun to have. So to use, we'll be bringing it out to the potluck that we're having in May. To observe the solar activity during the days. Okay, next slide, Eric. So, in our jump in here, this is the photograph that Eric took. He actually texted me this picture the day after. And I was gone at the time, but I was listening to the emails and the chatter. They had observed this really bright solar activity on the surface through the scopes, right? So
Mhm.
Eric, why don't you walk us through a little bit about the events of that day and what you saw and how you reacted, how you came to take this photograph?
Well, if I can, let me come back to here real quick and show your image. This one. So this image here is more of a real-time view of what we were seeing through the eyepiece, where around 3:30 or so, I think it was in the afternoon. I think Michael, you had already left by then, unfortunately.
Yeah.
But this very bright active region here was just so incredibly bright. Me, Doug, we've looked through the scope multiple times before, never seen anything that bright show up.
Went from sunspot. I was inside at the time. Somebody told me that something just kind of blew up on the sun.
Yeah.
So it just developed this really bright.
And they called you?
No,
You're gonna save the day?
So you gotta come out, take a look at this.
Help, Doug, the sun's exploding.
No, anyway,
So then I decided I was going to grab my little ZWO ASI Air computer, connect up another little ZWO camera, and put it into where the eyepiece would be on my personal scope, and took a 1-minute video, which I then extracted several frames, 629 frames within the 1-minute video, which I then did like a 50% stack on it. So half the frames. And that camera was imaging at roughly 25.5 frames a second to grab this still version. And so this image here from spaceweather.com on the same day, it's kind of showing the location of the sunspots. You can see that if I flip back and forth, you see how they are roughly lined up with the bright active regions here around those sunspots. But yeah, it was just an incredible event to see in real time. So unfolding.
So what we're kind of focused on and talking about is that number 3576. Go to the other photo there. Yeah, the big bad one there. So this photograph came from spaceweather.com. And go to the next slide if you would, please. And this is a website that Doug just introduced me to, and I'm totally amazed at it. So you guys remember that website address? It's simple, spaceweather.com. Go there every day and check this out. So we went back to the archives of the next day, the 11th, and this article is here, and it talks about this big sunspot, AR 3576, erupted yesterday, the 10th. They had a typo there. It said 2703 universal time. There's no such thing. So we figured it was a typo. It should have said 2203, which if we convert that to Pacific Standard Time, it's 2:03 p.m. That's right when Eric was shooting the photos. So that erupted at 2:03 p.m. They called it a solar flare at the time, an M-class solar flare. And huge thing, and if you go back to the photograph again, what I didn't realize, other photograph before this one, is that we see these prominences and these eruptions on the limb of the sun, right? Those don't affect us really. They're not aimed at us. But when you see something dead center in the sun, that's aimed at us, right? So all that energy, those solar particles are going to come flying at us. If they don't get here immediately, they're not traveling at the speed of light. They're going to get here the next day or a few hours later.
Eric, what we saw, that flare was actually the photons, and they do travel at the speed of light. Okay, so they were hitting us 8.3 minutes later. But the CME, the coronal mass ejection, the actual protons and electrons and so forth. It takes them 17 to 26 hours or something like that to travel that distance. So,
If you go to this spaceweather.com page. So keep reading this article here. They said it reduced an M9 class solar flare only percentage points from category X. We'll talk about the different categories in a moment. But then you see the photograph that we were looking at on the left is showing the different sunspots that day. And then the photograph in the middle is I'm not sure what bandwidth that's in, what frequency that's in, but they're showing you the flare that came at Earth. And to the effect that it actually caused shortwave radio blackouts over the Pacific Ocean. Doug's going to talk more about how these events affect us here locally. So the scientists classify these, I've learned, in these 3 different categories. If you go to the next slide, Eric, it's got a little breakdown of these X class. Those are the bad ones. They're the big ones, the major events that can trigger these planet-wide blackouts and grid outages. The M class are the medium-sized ones. C class are smaller ones, almost not noticeable. But these are measured in watts per meter squared, and they you see the chart on the right, and then here on the far right axis of that, you can see the A, B, C, M, and X. So as the intensity increases, they keep going, and those scales are logarithmic, so they're magnified in intensity greatly. But what we were seeing with that sunspot 3576 was an M9. So right up at the top of it, the M class, almost to an X class solar flare, which are the ones that now again will start to disrupt us with all kinds of different phenomena. Doug, why don't you tell us a little bit more about how these things can really affect us here on Earth, what they're doing?
okay, so we're looking at sunspots. Look at the sunspot. We're seeing these sunspots, the actual dark areas are holes in the photosphere. They're depressions, materials getting thrown back in. Those prominences you see going on in the out, they're happening here. So this will be the south end of these loops of magnetism.
The previous photo shows those prominences.
So you have one section will be throwing material up, and then it'll be diving back into that hole in the photosphere. Okay, and they're staying pretty much in the photosphere, the chromosphere. Okay, closed loop. Every once in a while, something underneath the photosphere shears that magnetic pole, and it releases. Okay, and it releases billions of tons of protons and electrons. And if they're pointing at us, there's another thing that has to happen. So these are the flares. Each one of these things are producing small flares. Okay, no big deal, until they hit a M9 or an X class flare like we saw. Most of them just stay in the photosphere, chromosphere. But if they get sheared off, then they come heading out. Not everything that heads out and hits the corona goes past the corona. Some of it gets absorbed in and pulled back in, and it's got to reach. Where's my number here? 600, yeah. That material's got to reach 618 kilometers per second for it to be able to reach escape velocity of the sun. So most of the stuff doesn't have that escape velocity, but if it does, if it hits the corona, then more physics happen, and it's the corona that releases another billion tons of protons and electrons and basically helium nuclei at us, along with carbon, nitrogen, oxygen, and so forth. Okay, that's what comes heading towards Earth. Usually, not. We are protected by our magnetic sphere. Okay, and so the magnetosphere, we're out here. The magnetosphere produces like a shield. It is a shield. Okay, that material comes in, hits that, and if it's comes in, it's streaming in daily. Where is it? There it is. The total numbers of the particles carried away from the sun by the solar wind is about 1.3 billion tons per second. Okay, that's what's heading at us. Total mass of loss each year is about 2 to 3 times 10 to the minus 14 solar masses, or about 1.3 to 1.9 million tons per second. There it is. That's the equivalent of losing a mass equal to Earth every 150 million years. So it's really not losing that much mass. But that's what's coming and hitting us all the time. At what's the velocity? Between 250 and 750 kilometers per second. And the density ranging between 3 and 10 particles per cubic centimeter. So it's wind. It's just, there's not much there, but there's a whole bunch of it, always and constantly coming at us. And it's hitting our magnetosphere. When one of these CMEs, these coronal mass ejection, all of a sudden it's not, your density isn't, where did I see it? Between 3 and 10 particles per cubic centimeter at 250 kilometers per second. It's coming at us at millions of miles per second. And it's billions of tons of it. Okay. And it physically pushes the magnetosphere in. And when it does that, that pushes our atmosphere in. And if we push the atmosphere in here, it pops out here and here. Elon Musk and his crew was really, really arrogant a year and a half or so ago. And they launched a series of their satellites, the Starlinks, okay, with 30 satellites. When a CME was due in. And it went up, and the CME hit us, and it expanded the atmosphere in these areas. And when his satellites, as they were trying to reach orbit, hit that area, much more dense than it should be, they lost momentum and they ended up in the Pacific Ocean. It cost him, I think it was $30 million or something like that. Good. Arrogance. So that stuff actually comes in. So Dennis is a ham radio operator, and my cousin is also a ham radio operator. And when this material comes flowing in, it also changes the ionosphere. And what it does is it moves it from being somewhat opaque, and where the signals will bounce up and then back down, so that they can pop across, huge sections of the Earth just by going up and bouncing back down. It becomes more transparent, and that their signal just goes flying out into space, and so they lose communication. If the CMEs, first of all, if the flare, the photons that hit us are strong enough, we're talking about X-rays and massive X-rays and ultraviolet light, that can actually damage satellites. And it comes through and some of it's in the atmosphere. When the CME hits 17 hours later or whatever, it can really, first of all, it can knock down low-lying satellites, it can blind satellites, and it can fuse some of the electronics. So there is a concern that a large enough CME could actually cause some major damage. And do you want to talk about the Carrington event? The Carrington event? Go ahead. All right. So it happened one time. It's happened. We've had a few CMEs that have actually done damage. I do remember March 12th March 13th of 1989. We had a public event scheduled, and all of a sudden the lights went out. What we found out was that a CME had thrown that stuff at us, and in Quebec, the material came flying in, and it got picked up by these power lines, and it picked up that energy, and it started tripping breakers everywhere. Now, I read that was just localized to Quebec. You had that video. You had that video, and they were talking about just Quebec. It took out the lights here, at least in Lodi, and I know Stockton also, because it basically started tripping breakers everywhere, and none of the power companies were set up for this stuff. Okay, power companies are now putting in material, putting in equipment to basically they can disconnect quickly. Yeah, because it's going to happen again. It will happen again. And it has happened. We know that it'll do it again. They're getting ready for it. But in 1859, there's something that's called the Carrington event. And the Carrington event, named after the astronomer Carrington in Britain, he saw this sunspot in 1859, and he sketched it, and so forth. And right afterwards, there were people that were playing with magnetometers here and there, and they were getting funky readings, basically picking up all these charged particles coming in through the poles. This is what causes the aurora borealis, aurora australis. And they were seeing northern lights all to the equator. The entire world was one big aurora. There were reports of miners in Colorado that this happened at 2 a.m. and they got up thinking it was daylight and started making burns because it was light. But that Carrington event, the sunspot is about that big. That is visible with your regular eclipse glasses with the naked eye, or in your, in your cameras, in your binoculars, so forth. But just
we couldn't see how big you were talking about.
So did you see the size of the? Are you sharing the screen?
Yeah.
Yep.
It's the one in the center.
But they can't really see you, but I turned.
When you said it was this big, the sun was off the camera.
Yeah. Okay. So actually, can you see me?
Yes.
It's that center one that we were looking at. The one that Eric saw the flare from. Actually, go back to that one. All right. Can you guys see that? Can they see that one?
They can, yeah.
3576. Do you have that? Did you have that one that had the 8 planet Earths lined up?
It's the last slide.
Oh, okay.
Do you want me to go to that?
Yeah. So this was also on spaceweather.com. This is the one we're looking at. And here is that sunspot. And here are the planet Earths lined up. You have 8 planet Earths. That's how big it is. Once again, here you have your material coming up here and diving back into these holes right here. They're always pairs. But that was the size of the Carrington event. So the sunspot doesn't have to be that big. It just has to be the energy that escapes. Directed and once again directed at us. So the little prominences you see feathering off on the end, those are heading out in different directions. Now, the sun rotates at different speeds at different elevations, just like Earth does, but because it's plasma, there's a disconnect there. And that's what makes the shear. That's how these things get sheared off, is the Coriolis effect. And part of it's moving faster than the other part, and you just get ripped apart. And that's where that can get sheared off, lose its connection to the sun, magnetic pole, and off it goes flying. It takes 25 days at the center, at the equator. It takes 25 days around, and I think it's like 22 or 18 days up towards the poles around. So these sunspots that we see 1 week can be coming around a month later, and some of them get bigger, and some of them disappear. These are coming around again, and we don't know what they're going to do when it's come back around. And we're looking, we'll see what happens. If that is something to look at, just before April 8th, hit spaceweather.com, take a look at the sunspots. Take a look at the ones towards the edge. Take a look at a few days before and look at the ones that are rotating off the edge. Because those are the ones you're going to see prominences and so forth thrown out. Or even loops and so forth.
So just real quick, in this image that we're currently sharing, is you see the prominences on the outer limb there. Let me finish. All these dark ribbon-like filaments here are also prominences, but they're not on the limb, they're facing us.
Right, exactly.
Yep.
So those are the ones that are going up and over, up and over, up and they kind of tunnel through. These are between the photosphere and the chromosphere. So these tunneling effect ones. But yeah, there's a sunspot right there throwing out stuff. There's a sunspot right there throwing out material. Same here, 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 here.
Do you guys care to see the original video of this?
We don't know what he's pointing at.
I'm pointing at all the prominences along the sun.
Do you guys in Zoom see the video?
Yeah.
So this is the original video. You can see how very disruptive the Earth's atmosphere is, making this very wavy. But you can kind of see the brightness here. But this is probably a good 20 minutes after the original brightening.
So in the hydrogen alpha scope, it was a pink area. And the center of the pink was a very, very light pink. So you're looking at the deep red of the hydrogen in the hydrogen alpha in the eyepiece, but there was a spot that went from deep pink to a very, very light pink in the center. We knew it was a flare. And so when I went out and took a look, first thing I did is I took my phone and I went to spaceweather.com. And for the day before that one they showed, and it said something about a big flare is happening right now. And they didn't have much of the details at that point. But that's when I knew what was going on, was because I went to space weather and actually I hit it and like nothing, and then it crashed and it changed it, and it was in real time. So hey, we just got shit thrown at us.
It makes you thankful that the sun's 93 billion miles away, right? It stays
Very,
there.
very thankful. Actually, though, that we have a magnetosphere in the Van Allen belts and so forth that actually protect us and protect our atmosphere. That's the reason we're able to live here.
Good, thank you, Doug, Eric, for
Mhm.
information and update. If we could go to the announcement slides, Eric, and we're kind of drawing to a close here. Have you seen our Facebook page lately? Oh, yes.
I have.
Good. Yeah. Yeah, thanks, Eric, John Shem, Bill Littell, working on the Facebook page. We've now got it posted where all the astronomy in the park events are up there for the next several months. So yeah, go check it out if you ever need to be reminded of what's in the sky that night or when they are. So, okay, I'm gonna run through March, April, and May's events. So this Saturday night's astronomy in the park. It's gonna be a beautiful night. Try to come out. Next week, Doug has a school star party on Tuesday.
Yeah, I need some help. Can anyone help me out on Tuesday? Anyone, please?
On their Jeep, is it Stockton?
It's in North Stockton,
What time then?
Sunset.
So it's gonna be after 7 o'clock?
Yeah. Set up just before sunset and
If it's gonna be after 7, then I can make it.
yes. It was a last minute thing, that was kind of my fault. She had asked for a date. To schedule something. I got back to her with a couple of them. She sent me an email, I missed it, and we didn't really reconnect until actually yesterday.
That's a Tuesday.
You're trying to get yourself fired from your public.
Yes, I am.
job.
Yes, I am. I should be fired.
Okay, so moving on into April, April and May are these kind of unique months where because of the new moons, Jeff has scheduled us for the start parties are either going to be at Highway 4, low altitude or high altitude, because there's only one in the month. So we'll decide the day before that time when what the best location is going to be. So you see that the April 6th and the May 4th start parties are indeterminate yet as to where we're going to be.
I just checked the cameras a day or so ago. Up at high altitude, and they look pretty snowy up there still. Yep.
That means they still may have snow at the heliport also. Okay, obviously the big day coming up, April 8th, for the eclipse, the solar max here is about 11:15 in Stockton. We were gonna have solar glasses available. They're here. If anybody wants to grab a few pairs, we decided that the club stock of solar glasses can be dispensed to the membership, because it's going to be several years, decades before we need them again. So it's up to a few pairs to take with you. I'm going to try to get somebody grouped together for the Stockton area meetup. April 11th is our general meeting. And because it's just a few days after the eclipse, and Eric's going to be driving back from Texas, he might not make it in time. Safe travels, Eric. But
Thank you.
all of you may not make it back and kind of have an in-person meeting. So it's very likely we're going to do a Zoom only meeting. Our presenters back on the East Coast, so that might work out well. So stay tuned to your emails and we'll let you know. I'm pretty sure it's going to be a Zoom only meeting, so not in person. Okay, April 12th, we're at Delta College. April 13th, back out of Oak Grove. Doug's got a star party in Mountain House on the 16th. Yep. Okay. Couple dates to put on your calendar or write them down now. Take note of Birthday Festival, April 21st. It's a great time out at Victory Park.
We're gonna need a few people.
Yeah.
Help out with, just to show people the solar show, so have a few broadband filters out there.
Yeah.
But there's 1,000 people out there.
Yeah, a lot of fun, and it's all day long, so we need a couple shifts
Yeah.
of volunteers. Then May 4th, like I mentioned, the Star Party. May 9th is our general meeting. And we've got a program for that. What is it? That's our, I think that's what Eric.
That's me, yeah.
Do the introduction to astrophotography.
Correct.
Presentations. Looking forward to that. May 18th, we're at Oak Grove Park, and that's the day of our club potluck. So May 18th, put that one on your calendar as well. And I'll send a reminder out for these dates. And then looking ahead, if anybody's planning a summer vacation, you want to go to Lassen National Park, north, and you want free accommodations, free entrance to the park, bring your telescope. We're collaborating with the Sacramento Club to do a star party there at the visitor center there at Lassen. It's great dark skies. I think it's like World 2. So it would be really nice. So that's July 27th. Most of the announcements, next slide. Eric. Here's our advertisement for Lassen, beautiful park. Not too bad a drive, little under 4 hours. So get a hold of me if you think you might want to make a vacation out of it. Next one. We mentioned this last meeting. Mark is hosting the astronomy, astrophotography section of the newsletter now. And Mark's looking for submissions. So here's a sample. It could be something simple like the night sky. Send it to Mark. There's his address there. It's also on the masthead of the newsletter. And give him a little information, what camera you used and what the location was. And I think we'll look forward to some members' photographs in the newsletter going forward. Next. Okay, I'm going to step aside and let you all read this letter that came, it's email that came to us, and I think it's self-explanatory. So let me just give you a minute or two. Let me know when you're done reading. Okay, y'all give a chance to read through that?
Yeah.
Okay, so Marissa Lamore brought this email. She's the coordinator for this exchange program. And she's looking for placement of it's a bunch of different exchange students that that their service handles. But this one in particular, because she's got this passion for astronomy. And I love what she wrote there, that I dreamed to be an astronaut with NASA. It's a big dream, but if your dreams don't scare you, they are not big enough. So it sounds like the girl's just loaded with passion. I mean, she's a U.S. State Department scholarship recipient, so I'm sure they're screened. There's more information at their website. If you want me to forward you this email, if you or you might know somebody that might be interested, it's what our club is all about. Fostering education in astronomy. So, okay, next slide, Eric.
Good. All right, so we were founded in 1950. That means next year is our 75th anniversary. We had talked about possibly getting some new t-shirts, jackets made. So I went over to the guy that does our t-shirts and said that we need to do something. And about 4 days later, he shot back this idea for t-shirts. Now, the one thing that's missing from it is I told website. It'll be on the bottom. So that's just it will be taken care of. The executive committee, I'll take a look at it. They all kind of liked it. We need to get other people's opinion, and what we need to do now is send it out to the membership to see if they want to spend the money, because that's the thing is we will have to have the membership vote on it, and it has to go in the form of into the newsletter. So,
Am I wrong, or is that 1955, only 70 years?
yes,
I think it's supposed to be 1950, right? But that number is not on the, isn't on the shirt anymore, right? Okay,
Yeah, it's 1950 to 2025, which will be 75 years.
yeah, okay.
We could put 1950 to 2025 on there.
I just want to make sure that that wasn't that little text below the front side logo.
People on Zoom can't see it, but right here it says, founded in 1950.
Okay.
So, but we definitely would put the, website right there, and I don't know, there might be room to put, 1950. or-
It's something.
Yeah, it's not necessary, so. Anyway, once again, this is gonna have to go to, the membership to get voted on, see if we want to. Just so that you guys know, 12 each of each size, small through, double XL or so, 84 shirts. Would be $1,142 plus tax. If we did 6 of each shirt, small through 4 XL, 42 shirts, $693.
I'm sorry, is there a minimum order?
There might be, and it's probably somewhere close to, 2 dozen shirts.
Okay.
But we can, I can
Maybe
see.
we need 75 years in counting. It lasts more than a year.
So the other people have talked about over the years about maybe getting jackets made, and I think this is the opportunity to do so. Len sent a couple of things with soft shell jacket with embroidery on the left chest. 50 small to extra large, basically $52 a piece. The 3XL were $56 a piece. And then there's a $75 charge for digitizing the logo. I can ask about that one since I have one. But no, you shouldn't need that 75 for digitizing as well, because I've got the vector of and you shouldn't need it to be. So it shouldn't cost us anything on digitizing. Once again, like I said, this has to go to the membership to vote on something, so. Your input on this would be appreciated. Thumbs up, thumbs down.
Thanks, Doug, for doing the legwork on getting this. A celebration of t-shirts.
So are you looking at ordering just jackets or shirts and jackets?
Well, the way it would be we order the shirts and those are screen prints. They set up when they print all at one time. Jackets are embroidered, so one at a time, one of them. We have t-shirts for sale. You all should have one. They're right here in the box if you want to buy a t-shirt.
Virtual t-shirts. You have any of the Einstein t-shirts left?
There are a few Einstein ones. I just didn't grab them.
Great.
But there are some Einstein ones maybe next month. Well, okay. All right, we need to wrap it up.
Okay, thanks, Doug. Next slide, and we're just about wrapped up here because we're about to turn into pumpkins. So, Pat, you brought this up. This is Comet Ponds Brook. And I was reading where it could possibly be visible right now in the night sky because it's at a currently a magnitude 6.3 in Andromeda. It's kind of low, but on a good night we might be able to catch it. Somebody already taught some great photographs of it. It's a periodic
71 years.
comet that is it's every 71 years, I think.
Yeah.
Yeah, and its perihelion is coming up in April, when it's going to be as bright as 4.5, so it could be almost naked eye.
It's roughly an 18-mile diameter
Very much.
comet.
So, and it could be, what I was reading, could be visible the day of the eclipse, because this, from my Stellarium, my sky program, spotted it between Jupiter and the Sun, right there along the ecliptic at that time of the morning. So Jeff, be looking for it They're between Jupiter and the sun, between the eclipse, so. I don't know how magnitude 4.5 is gonna show up, during the eclipse in totality.
That would be pretty rough unless you had binoculars and were really good at finding stuff like that, but that's pretty dim and not sure I want to burn precious eclipse moments looking for that. But knock yourself out.
Yeah, it might be easy to find though, because you've got the sun and the Jupiter, and it's kind of on that same line between them, so it might not be too much hunting.
Well, magnitude 6.3 is dimmer than the naked eye on a dark night, and we're going to have an eclipse event where it's about as bright as a full moon, and you're only 30 degrees from the sun. So my guess is naked eye is absolutely out. Binoculars is a maybe. Me personally, I got other cool stuff to look at. I don't know.
Good question, though, Pat. Thanks for bringing that up. So that kind of concludes our announcements. Any discussion or anybody have any comments you'd like to bring up before we adjourn?
Actually, I did. Jeff, if you could share the screen real quick. You were showing the corona, and I had a question.
You're asking me to show my screen of one of my.
Of your presentation, yes, sir.
Yeah, okay. Well, give me a second to screw up a couple times here. Yeah, I am doing it. So share screen, blank.
And it might potentially be a stupid question, but
I love stupid questions. I'll say this: there are no stupid questions, just stupid people asking them.
oh, okay. I mean,
Okay, what screen did you want me to see?
it was towards the end of your presentation. That one right there, the one that your cursor's on. Okay, so you have the moon right there, and then you have the corona, but then you have this pink coloration that
Yeah.
kind of looks like flames. What
there.
is that?
Okay, so this is a prominence, but this is about 15 stacked pictures. So while I was looking at the eclipse with my eyeball,
Uh-huh.
I had my hand on my camera and I clicked a 4,000th of a second exposure without even looking in the scope, moved to a 2,000th, clicked it, moved to a 1,000th, clicked it, moved to a 500th, click. I just kept adjusting the exposures and clicking pictures. Then when I put them all together, keep in mind that on each of these pictures, the moon was in slightly different position.
Right.
So that's why this flare looks like it's in front of the moon here. It's because when I stacked them, they lined themselves up on these pieces of information here, but the flare was with respect to these guys and the edge of the moon. Keep in mind that the dark moon was moving, and so this stacked over and over and over. So it looks like it plugged itself in front of the moon a little bit. But what this is just a solar prominence on the side of the moon or the side of the sun, stacked with about 15 pictures where the disk of the moon was not static.
Okay. Yeah, because I was wondering if that could be seen with the naked eye.
Oh, heck yeah. Okay, naked eye, I don't know, but like in binoculars or a small telescope, absolutely. That's one of the things I was fixated on was that solar prominence there, because this is the prettiest part of an eclipse right here.
Right.
But then you go around and you look at the chromosphere on the side and you come over and you see that flare. That is the most coolest electric hot neon pink you ever saw.
Wow.
And it's spectacular.
So that's not an artifact then. That's like essentially true color.
That's the real deal. That's very close to the true color. One of the plans I had for the eclipse was taking a photosphere before the eclipse, taking a photosphere shot with my solar filter, stacking corona pictures, but I also wanted to get a hydrogen alpha picture. And then I was going to stick it all together. It's going to have my stacked corona, and I was going to have my photosphere in the center. Then I was going to have the chromosphere and flares just plugged in along the side. But instead of using the hydrogen alpha color, I was going to color change it to this hot neon pink so it would be a more realistic thing. But I'm having problems with my hydrogen alpha scope. I might have Eric take a look at it. I cannot make it tune. So,
wow.
so if I can make that happen, I'm going to do that. But that is a beautiful neon pink.
Wow, that's kind of crazy. And then
Hey,
the second,
We've got 10 minutes to wrap up, so we need
okay,
to. Let you contact Jeff offline.
yeah, I will. That's a good idea.
So, hey, thank you all for attending this evening. And Jeff for a great meeting. So let's give them a round of applause. Good seeing you all.
Michael, if you have a question, email me or call me.
Will do.